Hi, today we are going to be working on solving exponential and log equations. And so we're going to look at something that's pretty basic. You can just use logic, right? To say, hey, how many times do I have to multiply 2 by itself to get 16, right? Or you could look at it more, not logically, but more methodically, and that is to say, well, wait a second. 16 is 2 to the fourth, and if we have the same base on both sides, then x must equal 4. Doesn't matter which way you do it, ultimately you get the same answer. All right, so here we've got a natural log problem, and our first step is going to be to change a natural log into log base e. Because once we have a base, then we can change our log equation into an exponential equation. And so how do you know when to do that? Well, I look at this log equation, and I'm like, I have no idea what x should be, so that log or natural log of 3x minus 2 should equal 7. Kind of crazy, right? You can't answer it. So then you hope that if you switch it to an exponential, you can answer it. Now we remember when we switched a log to an exponential that the bases are always the same, and that so then we know to start the equation with an e, and we also notice that log answers are always the exponent. So that's 7, that's why we pop the 7 up there, because the answer to a log is always the exponent of the base of an exponential. And so then of course the 3x minus 2 go to the other side. So now you're like, well, e to the 7th, that's not going to help me. Well, sure, we've got an e button on our calculator. So what we're going to do is we're going to get the x alone. We're going to go ahead and add 2 to both sides and then divide 3 by both sides. Then we'll pick up our calculator. And if you're using your phone calculator, be really careful. You want to use parentheses for your numerator before you divide it by 3. Or you could just do e to the 7th plus 2, hit enter, and then divide by 3. Either way you do it, if you have to use your phone, just be careful, and you should get 366.21. So we looked at a natural log problem that we couldn't do, and we changed it to an exponential with a little help from our calculator, we were able to do. Okay, so now we're looking at an exponential with the base of e. Once again, I'm looking at this, I'm like, I don't know, 4e to the 2x equals 16, what could x be? I don't know. So that's telling me that I'll probably want to change this. And so first, before we can change it, we got to get rid of that 4. So we're going to go ahead and divide 4 by both sides. And then we can go ahead and change it to a log. Once again, the base of an exponent is always the same as the base of our log. And the 4 goes over here, and the 2x goes there. So I'm just repeating something that you've practiced many times. And so now we're like, oh, log base e, well, that's natural log, right? And so now what we're going to do is we're solving for x, so we're going to divide both sides by 2. And this is when we pick up our calculator. When we've isolated x, we're going to pick up our calculator and put natural log of 4 divided by 2, and we get 0.69. So another way of looking at this, now I always prefer this way. I always prefer if we're looking at an exponential to just straight up switch it to a log equation. Sometimes people, when they're looking at exponential, they do this third step right here, which basically is saying, let's see, it's saying, you know, if we have an exponential, then why not just take, especially because the base is e, why not just take the natural log of both sides? It's kind of a little shortcut way of doing it. We get to the same place, that 2x equals natural log of 4, which is the same thing as we have right there. Once again, I'm more of a fan of the first method because it allows us to do other problems that this second method doesn't. All right, so here we go. We have an exponential. Let's go ahead and see how we can isolate x as much as possible and decide on our strategy. So we're going to divide both sides by 2. Then we're going to add that 1. And once again, 3 to the what equals 6? I don't know. I mean, I can't even put that in my calculator. So I know that I have to change this exponential equation to a log. So once again, our base is going to be the same. Log base 3, we bring the 6 over, we bring the x over, because we know that log's answer is always the exponent. Okay, actually the power part. All right, so we go ahead and, oh, sorry, it peaked a little bit, and I'm like, pick up your calculator, right? And you're like, well, it's over, I don't have base 3 there. That's fine, we have the change of base formula. So we put the base in the basement, right? We'll put log. Now, once again, we don't see a base anymore. When we don't see a base, we know that means our base is 10. And so we have a log base 10 of 6 divided by log base 10 of 3. But once again, on your calculator, you just push log because that implies that your base is 10. You hit enter, and you should be getting 1.6. I'm sure I rounded that up. All right, or down. All right, now this is an example that we haven't seen before because we have two exponents with the base of e, and we're like, ooh, so what are we going to do? Excuse me. Well, first we're going to do some side work. You're going to see both work, but go ahead and look over here in the orange square or orange rectangle. When I see e to the 2x minus e to the x minus 20, I think, well, this looks like a quadratic, like x squared minus x minus 20, because it's a trinomial. And instead of like, imagine that the x was 1, right? Then we'd have e to the 2 minus e minus 20, and that makes it look more like a quadratic. And we know that we can factor it by this quadratic by saying x minus 5 times x plus 4, right? Because negative 5 times 4 equals negative 20. Negative 5 plus 4 is negative 1. So we're going to use this idea to go ahead and factor what was given, because as it's given to me, we can't solve for x. We've got to break this down. And so we go ahead and instead of x, right, we're really substituting x for e to the x. So we're going to go back in and say, well, instead of the x's, I'm going to put e to the x. But that negative 5 and 4 work, right? And if you don't believe me, go ahead and distribute the e to the x to both the negative 5 and the 4. Distribute the negative 5 to the e to the x and the 4. Combine like terms, and you are going to get back to the original left side of this equation. And so when we have something times something equals 0, we use multiplicative property of 0 to set each of the factors equal to 0. And so when we do that, we get e to the x equals 5, and e to the x equals negative 4, which is going to be a problem there, right? So let's just focus on the left side before we see the problem on the right. So on the left, I'm going to go ahead and add the 5 to both sides. And then I'm going to say, well, it's exponential, but I need to set it up as a log so I can solve it. So I do that, and then log base e, of course, is natural log. Pick up my calculator, natural log of 5. I rounded that to 1.6. Now, when we look at the second part, when we set the second factor equal to 0, e to the x plus 4 equals 0, but e to the x equals negative 4, and that negative should tell us, yeah, e is a positive base, right? And you're never going to get a negative number, but we could go ahead and mess around with it. And I'm looking at this going, what did I do? Log base e. Okay, negative 4 equals x, and the natural log of negative 4 equals x. Try to put natural log of negative 4 in your calculator and tell me what you get, which it makes sense because of what we had right here. A positive base can't be raised to anything that's going to change that into a negative. So we just have one answer, 1.6. All right, solve the following log equations and round your answer to 3 decimal places. All right, well, I can't do that round to 1 decimal place anymore. All right, the first thing we're going to do is go ahead and, well, there's 2 ways to do this. I was going to say divide by 2, but what I decided to do was more the condensing idea, where we know that we can take that 2 and pop it up to the x. It's actually x squared. And so when we do that, we know that also when we don't see a base, the base is 10. And so now I'm like, well, log base 10 of x squared equals 5, no idea. But, right, when I say no idea, then I know if I change it to an exponential, maybe I will have an idea. So let's go ahead and change the exponential. The base of the log is the same as the base of the exponent. And of course, we pop the 5 here, the x squared goes there. And we can say, to isolate x, we'll take the square root of both sides. And so x is going to be the square root of 10 to the 5th. Pick up your calculator, do that, voila, 316.2. I believe the alternate way would be divide both sides by 2, and then go ahead and change that log once again to an exponential. It's actually kind of a little bit, maybe the same, but 10 to the 5 halves, of course, is saying 10 to the 5th power, and then take the square root of that. So the same thing. All right, here we've got natural log of something equals natural log of something else. Well, we've learned in the different properties that, well, like let's say natural log of 10 would equal natural log of 10, right? So if 2 natural logs are equal to each other, then we know that what we're taking the natural log of has to be the same. And so we use that idea to say, well, if we want to make these two natural logs equal, we have to set square root of x plus 2 equal to x and go ahead and solve and see what x would make both of those equal. So the first thing we're going to do is we're going to square both sides to get rid of this square root. And then we have x plus 2 equals x squared. And so we've got to bring everything to the left or to the right because we have two terms that have x in them. And so we see clearly we've got a quadratic trinomial that we're going to need to factor. And so we factor it, and that's great because we can set both of those equal to 0. And we do. X minus 2 equals 0, x plus 1 equals 0. And as we solve, we get x equals 2 and x equals negative 1. And you may say, Miss Overby, why did you x out x equal negative 1? Well, whenever we are squaring both sides of an equation, we have to be really careful, right? Because we could have an extraneous solution. And because, right, if I had negative 4 equals 4, and I decided to square both sides, I would have 16 equals 16. So by squaring both sides, sometimes you come up with a true statement that's really not going to work with the original equation. And so we got to be really careful. We got to plug both answers in to make sure that they both work. So we plug in 2. And really what we're looking for is, natural log, if I plug in a 2 there, it's natural log of 2, right? Because 2 plus 2 is 4, square root of 4 is 2, equals natural log of 2. And there's no problem there. And also we're looking for making sure that we're not taking the natural log of a negative number. So when we see that x can also equal negative 1, we're going to plug that negative 1 in, and there's no problem on the left side, right? 2 minus 1 is 1. Natural log of 1 is natural log of 1. But we plug in the x over here, and it's natural log of negative 1. So obviously there's two problems. Natural log of 1 does not equal natural log of negative 1. There's that. But also that we can't take the natural log of a negative number. All right, so we're going to use our rules of condensing to help us here because we can't solve unless we're just looking at one log. Just one term can have a log in an equation, not two. And so we remember that we can rewrite this as one log, but with the division, right? So subtraction that involves two logs can be condensed to a log where we take the x over the x minus 3. Once again, when we don't see a base, that implies that our base is 10. And when we look at this, we're like, we don't know what x is. And so we go ahead and change this log equation into an exponential equation. And then we see that we have an x, both in the numerator and denominator. So you can look at this as either, you could put a 1 underneath the 10 and then cross multiply, or you can just multiply both sides by x minus 3. That helps. And so, then I'm like, oh, what did I do here? All right, so then you've got the 10x minus 30 equals x. And so, I see what I did. So what I was trying to do is I was trying to subtract the 10x on both sides. And then, so that's what I did first. I'm going to subtract the 10x from both sides. I guess I'm showing you over there in the yellow. That I get negative 30 minus 9x. And then I'm going to go ahead and divide by negative 9. So I get x equals 3.3. And that's it. I know that I flew through that. Anytime you need to just stop and slow down and look at the work, that's a great idea. This section really pulls in so much of what we've done in this chapter. It's a really nice way to end the chapter. Thanks for joining me. I look forward to seeing you in class.